Hey, good morning, everyone. Thanks for your patience. We're just doing a little kind of final minute editing and a little getting prep for you guys. So good morning. Thank you for coming. Just a few quick announcements on my part, and then we'll get things rolling along. The other day, there were a number of Master Gardeners who assisted over at Gaithersburg High School for a planting event, and I heard that went really well. And I want to thank those Master Gardeners who came and assisted over there at Gaithersburg High School. I think it went really well. A lot of parties different groups were there. Looks like we will be doing more of this in the future, probably a similar event in the spring with the middle schools. So again, I thank everyone's cooperation on that, those folks that came. I think it's a great hands-on opportunity to show some of the skills the Master Gardeners have working with the youth here in Montgomery County. Just a quick mention, holiday parties December 7th. Put that on your calendar. You're going to hear more details forthcoming. That'll be great. So the next big thing on my list of announcements is we're going to do the election for the 2024 board. And so with Linda's help, she's going to present that, and then I'm going to set up a poll question, guys. And so it's just a simple yes or no question. And I'm going to give a minute, about a minute. I'm going to get my little clock up here to do it, and then we'll just close it up, and that way we can just keep moving along. Give me a second to get my clock set up here. Go poll question set up. So if you can, let me find where. Oh, there it is, right there on the top. All right. So I don't know. Well, yes, it's running. All right, I was going to say, is it up? Obviously, it's moving very quickly. It's like a horse race. We're up to 43, so I didn't even track the time. So I'm just going to give it a little bit. Thank you, guys. It's slowed down quite a bit here. We're at 79. It's maybe somebody will push it over to 80. Feel better. Nice number. I don't know. I'm maybe asking for a lot. Anyway, so give me a few more seconds. And that'll probably put close to a minute. Looks like we're set at 79, Linda and Renew. So we have 79 approving out of 79. And I'm going to probably let that be the official end of our poll. And we will move on. Thank you, everyone, for voting. And I'm going to hand the baton over to Renew at this point.
Thanks so much, Steve. And thank you to everyone for your ongoing support of the board and for approving the 2024 slate. Really appreciate it. And a big thank you to all those that are serving in leadership positions with me. We have a couple of announcements that I'd like to make, but I also have some of our Master Gardeners that would like to make their own announcement. So with that being said, I will hand the virtual mic over to Beth Myers for an announcement regarding plant clinics.
Okay, thanks, Renew. This is an announcement regarding, yes, plant clinics. And if you are looking for some flexibility in getting in your volunteer hours, this one is for you. We're looking for someone to coordinate Saturday plant clinics at Brookside Gardens. And you do not need years of experience to do this. First year folks can do it just fine. Ask me how I know. And we'd just love to get someone to take on this one. And if you'd like to talk about it, you can contact me, Beth Myers, that's Meyers. Give me a call at 301-502-1630, or drop me an email at Beth R. Myers, Meyers, at yahoo.com. And I'd love to talk and hope to hear from somebody. All set. Next person.
Thank you. Linda, over to you.
Okay. I just want to remind everybody that there is a horrible, horrible invasive weed. It is called Canadian thistle. And I know all about it because I kept trying to get it out of the demo garden. If you have this thistle in your yard and it's kind of pumping up everywhere, you have to go very, very, very deep until you get the little root hairs out. If you just break it off, it'll come back. If you break off any of the um, leaves as you're taking it out, it will come back. It's a horrible weed. So everybody look around for that thistle that's popping up everywhere and get very, very deep to pull it out. Thank you.
Thanks so much, Linda. So for the next announcement on behalf of Therapeutic Horticulture, they would like me to share that after a 3-year hiatus, the Therapeutic Horticulture Committee will be hosting an in-person workshop and meeting on Wednesday, November 29th, so right after Thanksgiving, from 9:30 to 11:30 a.m. in the garage room at Durwood. And anyone with an interest in therapeutic horticulture are welcome to attend. While the workshop will cover some internal committee matters regarding therapeutic horticulture, there'll be some introduction to the specifics of how therapeutic horticulture operates. And for anyone new that's interested in joining, there's an opportunity to connect with the leaders of our 15 programs that we have across the county. There'll be some discussions, presentations from various leaders highlighting the different programs and projects. There will also be a return of the annual materials exchange at this workshop. And the Therapeutic Horticulture Committee chairs are asking for any Master Gardener donations of craft, decor items such as ribbons, trims, spray paint, dried flowers, and small containers suitable for floral arrangements that you could possibly contribute. These items could be partially used. That's welcome, and anything that you're ready to discard. So perhaps during COVID, you or your family members might have taken on some craft projects, and maybe there's some leftovers. So those are the things that we're interested in. If you have or could collect any of these items to donate, you could please call or email one of the therapeutic horticulture chairs. So Lisa, Wendy, and Paula, and Carol has kindly put their contact details into the chat. And if you have any photos of things that you're like, I'm not sure, but maybe this would count, that's welcome as well. So really welcome any and all contributions. And if you're interested in attending the event, please contact the co-chairs with those contact details that have been mentioned anytime before November 27th, just so they can plan accordingly. One more request from the Therapeutic Horticulture team. The group that works at Brook Grove is also looking for mugs without logos and any 2024 calendars that you might have around. If you wish to contribute either of those items, please bring them along to the holiday party. Vivian Burke will be collecting them in December at the holiday party. I did want to thank in regards to our recent survey. It's still open in support of the Mission in Motion task force. I'll pop the link in after I finish my announcements, but really appreciate we've had about 150 survey responses, which is amazing. And we're really looking forward to getting feedback from all of you. So if you haven't had a chance, it just takes a few minutes to complete the survey, and we really appreciate the time that you spend sharing your input and feedback. I'll also pop into the chat email address for anyone who's interested or just contemplating potentially being part of the task force. The task force is co-chaired by myself and Mandy Gordon, who I know is on the line today as well. So we'd really welcome anyone who's interested. And then finally, Steve's already mentioned the holiday party. Again, it will be located at the Heritage Hall at the fairgrounds, same location as last year for any who joined us. And please keep an eye out on Groups.io for a registration link that will be available as soon as possible. So with that, I will turn the virtual mic over to Linda and Gloria for acknowledgements and then to introduce our speaker.
Great. Thank you, Renew.
Thank you.
Let's see. Okay, so we did the slate of officers. So let's go to the next one. Go ahead, Gloria.
Morning, everyone. We'd like to recognize several groups this morning, beginning with our fabulous fairgrounds. Slide 2, yes.
Mhm.
In a photograph on the left to right, we have Beth Fisher, Pam Bates, Marion Mistrick, Stan Fisher, Alex Friedman, Chris Wills, Sherry Marshall, Michael Pariser, and Jay Everhart. And then not pictured, team members who were not in the photo: Dick Evans, Irene Ekstrand, Sue DeGraba, Sue Krebs Smith, Amy Freeman, Steve Erickson, and Christopher Lewis. And in the photo, if you happen to be at the fairgrounds this year, you probably saw Dirty Gertie, who seems to be the mascot at the gardens. Anyway, fabulous fairgrounds team. Thank you for all you did. And now in the next slide, we have our fantastic Master Gardener Fairgrounds leadership. And Sherry Marshall was the chair of the Fairgrounds Committee and says she can't single out just one person or even several people because you all worked as a team. So some fair statistics. It was pretty fabulous. We had 4,480 contacts, the most ever. 70 open positions staffed by more than 60 master gardeners. 280 volunteer hours accrued during the 9 days of the fair. Thanks to Sherry and Michael and all who volunteered in any way. It really was fantastic. Thank you. And then, next slide, please. We'd like to recognize therapeutic horticulture and some new people to our group. But first, let's talk about the leaders of the therapeutic horticulture: Paula Brooks, Wendy Ban, Lisa Diamond. And they want to extend recognition and thanks to all the many volunteers who bring joy of nature, flowers, herbs, and our local environment to shut-in residents at nursing homes and assisted living facilities across the county. This work has been very collaborative and requires the efforts of the whole therapeutic horticulture community to accomplish it. So the two interns that we'd like to recognize are Jean Kennedy and Jolene Cannon. Jean was a 2022 intern who began at Byron House, Brighton Gardens, and Grace House, where she was instrumental in reviving the program after the COVID shutdown. And it's highly unusual for an active volunteer to be at 3 different locations because they meet each month and the preparation requires many hours. Jean is a self-starter, bringing creativity and organization skills to each session. And Jolene began volunteering also in 2022, and she was described as a breath of fresh air at Brighton Gardens and Grace House. During the shutdown, she started seeds with Lily Birch and grew them in under grow lights at home, and then later planted them with the residents. Jolene loves to interact with residents and always has a smile for them. And she was also instrumental in reviving the program at Grace House. And then the next slide, please. Molly Moran is, well, the words to describe her were indispensable, commitment, and drive. That Molly's role in the therapeutic horticulture programs at Marion Assisted Living and Lay Hill Healthcare. During the shutdown, she made flower arrangements and delivered them to the facilities. Now she plans, prepares, and presents educational programs in person for the residents, and always includes a floral project for each participant to make for themselves. And then Eleni Clark. brings exceptional creativity to educational programs at Byron House, gives attention to detail, and has in-depth presentations. She brings hands-on materials to the programs, and so the residents can observe, touch, smell, use their senses. And Eleni raises the bar, and the therapeutic horticulture programs are enhanced by her contributions to. So thanks, and we appreciate all of the people who are receiving recognition this morning. And we can't just say enough about you in just a few minutes, but we really, you deserve the recognition. So thank you all.
Okay, and moving on to Harvest Festival. Harvest Festival took place on a chilly, misty October 7th. It had been 3 years since the last Harvest Festival, but on this day, everybody had a great time. There were several activities for families, and here are some of the pictures from that. We want to give a big thank you to co-chairs Mike Welsh and Taffy Turner. Taffy and Mike would like to give a big special thank you to the following people. Vivian Burke, who organized the Tussie Mussies. Barbara Wheat Jakes, who consulted on the Harvest Festival setup and operation, and she also ran the bug game. Julia Horman and Gloria Sherman, who ran the Make a Butterfly and Paint a Pot table or tables. The Durwood Demo Garden team for fabulous garden tours. And Cam Rylander, who's an intern, for lifting all the heavy stuff during the setup. And the kids loved him working at the Tussie Mussies. So thank you to all the volunteers for Harvest Festival and the people that took lead with their activities. And next, we have Close Encounters with Agriculture. It's been taking place for the last 4 weeks, and we'll finish up this Friday. About 200 or 300 fourth graders descend upon Durwood every day for instruction in about 10 areas of instruction from about 10 a.m. to 1 p.m. Here are just a couple pictures that I was able to take over the past couple weeks when I was out there having some fun. We want to give a big thank you to Judy Rosenthal and Robin Hammer for co-chairing this event. I know it's hard to organize all those volunteers, but you all did a great job and we wanted to really thank you. Judy and Robin would also like to give special thank you to Judy Termini, Karen Seitz, Amy Prewis, Shelley Ray Reddick, Linda Waters, Edith Bowler, Judy Weaver, Marcia Matera, and all of the 2023 interns that came out to volunteer. There were a lot of interns out there, and it was great to see everybody. So thank you very much for making Close Encounters so enjoyable. And as mentioned before, we have our holiday potluck party coming up on Thursday, December 7th. So December 7th. So no speaker, just a party, which includes you bring a potluck item. We'll have lunch around 11:30. After we have lunch, there's an awards presentation for outstanding service and Lifetime Achievement Award winners. And then we'll have our gift exchange. It's back again this year. So find something for $15 or less and bring it to the party. And we'll do a little gift exchange at the end. Just a reminder, this is at the fairgrounds at the Heritage Hall. At the Heritage Hall. Okay, I'm going to stop my screen. And I'm going to introduce our speaker for today. So our speaker is Phil Frank. Phil Frank is a science journalist, a TV producer, writer, and director of nonfiction films. His programs have been seen. Am I okay? Oh, there you go. Okay. His programs have been seen on major TV networks, including CNN, Discovery Channel, the History Channel, and the Science Channel. While interviewing honeybee experts for a National Geographic film, Phil became captivated by bees. As he puts it, he fell down the honeybee rabbit hole hard. Now he has 15 hives on his deck, and a glass-walled hive in his kitchen. To help educate beekeepers, Phil developed and runs websites for the Maryland State Beekeepers Association and the Montgomery County Beekeepers Association. He designs beekeeping curricula and teaches honeybee biology. He recently published a honeybee book and is currently about to publish the Spanish version of it. And this year, he completed a multi-year program to become a master beekeeper, certified by both the Eastern Apicultural Society and separately by Cornell University. So we want to welcome Phil to our meeting today. Thanks, Phil.
Hi, I'm so happy to be here. I think that beekeeping clubs and gardening, master beekeepers have so much intertwined, similar goals and help each other so much. I love talking about bees, so you're the perfect group. You mentioned that I run some websites, and one of them is the Montgomery County Beekeepers.com. And what might be useful to you guys is I have 50 different plants listed here. They can be sorted in any way, but what they have in common is that they all are helpful for honeybees and native bees. And you can sort the columns by things that you'd be interested in, like blooming period, whether they grow in shade or sun, and other needs. So I wanted to point that out, and I hope you can visit there. But you guys are master gardeners, so I'm hoping that maybe you can give me some feedback and suggestions of plants to add to their that help honeybees, because not all flowering plants are equal for bees. Some don't provide anything to bees, and some just parts of the day and for short times. So anyway, I want to give you an overview of what we're going to discuss today. What makes a bee a bee? We all kind of use that word without much discretion, but there are specific things that make a bee a bee. How I got into honeybees, why bees are vital. We all kind of know bees are important, but I'll just give you some very specifics. Why they're irreplaceable. Honeybees are amazing creatures, and there's really no other animal out there like them. How bees make honey, again, we all have this sense of how it happens, but I'll just give you the quick rundown with some interesting specifics. Honeybees are crazy interesting because their bodies are like Swiss Army knives. They have all these different gadgets that they use to get their work done. So I want to show you some of those because I love talking about them. So here's a bit of a warning. We are going to get into some sex lives of bees. So that section is rated R. It has sexual content, bee nudity, and some stinging language. So I hope that's okay. If it's not, you can turn off your screen. And then we'll wind up with what's killing the bees and how you guys can help. And again, as master gardeners, you guys are it. I mean, it's all on your shoulders, really, to help the bees. So what is a bee? What makes a bee a bee? So unlike 1 million other insects, these bees are covered. They have three things. The first one is they're covered in branched hairs. And those hairs are important because, as you can see in this micrograph, they help trap the pollen. So it's an interaction with the pollen, and it helps them carry pollen around. The second of the three things that makes a bee is it has special hairs to carry that pollen. So they pack the pollen in these special hairs that are either underneath their abdomen or in the honeybee on their hind leg. And it's just like a basket. It's called a pollen basket because it really does hold it in there. And the third thing that makes a bee is their only food source are pollen and nectar. So a wasp, for example, is a carnivore, whereas honeybees are vegetarians. So now you kind of know what makes a bee, and you can feel comfortable. The only trouble is that describes 20,000 species of bees, and 4,000 of those are in North America and Mexico. We've got about 400 here in Maryland, and they come in a lot of different shapes, sizes, and colors, some metallic green. But the only one that we keep beekeepers, the only ones that produce honey and that we keep in North America are the honeybees. So I was doing, as Linda said, a television program for National Geographic, and that was my introduction to honeybees. I knew nothing about them other than they had something to do with pollination, and we certainly got honey from them. But the arrow is me. And once I started learning about bees, they're so crazy interesting that I couldn't help it. I just kept learning more. And then about a year later, I ended up getting my own bees. And then, as you know, bees stay inside in the winter, except that's why I built a glass observation hive in my kitchen so that even in the winter, I can watch them because they don't hibernate. They become less active, but they're still doing things, and I can watch them all year round. And I had no idea when I started getting into beekeeping that I'd keep falling down that rabbit hole. So every year, busloads of children come to my house and they look at these honeybees, and I give some different stations around my house where they get to hold honeycomb and taste honey and things. And while I was trying to show these kids and other visitors about the bees, I was having a little bit of an issue. I needed some way to show them this tiny little eggs that are in the backs of the cells, and they're hard to see. And I ended up talking with my hands. And that's what led to creating this book, Hive Tour. So instead of having to talk about it, I just turn to the page and I show them what an egg looks like and where they can find it. And we also use this at, I heard you mention earlier, Brookside Nature Center, where our crew has an observation hive. So on Saturdays, they use some pages out of this book. I'm just going to give you a quick idea of what is a beekeeper and how bees are kept. You've seen these boxes out in the field. You know the bees are in there. This area, the bee yard, it's called an apiary. This one happens to be on my deck. Bees are friendly. You don't need to keep them way out in the field. They don't want to come sting you. But why is it apiary? When I was interviewing that guy at the beginning, who's a world-renowned beekeeper, researcher, and figured out some pretty cool stuff, he said, well, come see my apiary. And I said, apiary? I thought that's where you kept birds. No, that's aviary. As I said, I didn't know anything getting in. But apiary, that comes from the Latin name for honeybees, Apis mellifera, so apiary. So all these different stacks of boxes are individual colonies of bees. They have one queen. They have tens of thousands of workers. They have nothing to do with each box. They all come back to the same box, and they don't, they're completely independent. And as the beekeeper keeps bees in these boxes, everything is modular. So the stack is made out of individual boxes, and you can take the boxes out. And as a beekeeper, you need to do this in the springtime every 7 to 10 days. Take the whole thing apart, look through it, because you're looking for diseases and pests that you need to catch early and manage to keep your bees healthy. So if we look inside that box, the modular part of it continues. It's all these hanging frames, kind of like file folders hanging in a filing cabinet. The beekeeper would take this out and look at it. And if you can see the shiny part in the wax cells, that's nectar that the bees have collected already and that they're turning into honey. If you pulled out another frame, this one, they're raising babies. So it's down here, the white, those are larvae in the bottoms of the cells. And up here, after 7 days of being a larva, they cap it over, and just like a caterpillar turns into a butterfly, the larva spins a little cocoon under that capping in the cell and transforms into adult and makes its way out. And there's only one queen among the tens of thousands of bees. And as a beekeeper, you need to be able to pick her out. And I'm sure that all of you see the queen right now. Actually, I picked the easiest picture I could find to show you the queen. And if this helps a little bit, maybe you can find her. And that's her. So bees sting. And as a beginning beekeeper about 10 years ago, I was certainly going to wrap up and not let any bee get near me. I was a little bit afraid of them. And so I put on my bee suit, and here's just a little word of warning. I put on my bee suit. I worked the bees for a few hours. Turns out that I was open the whole time because it's a double zipper, and I didn't realize. But the lesson for me was I was completely exposed to these bees, holding and picking up the frames, and nobody bothered me. I didn't get stung. So why are bees vital? So you guys are master gardeners, but just a quick review. Pollination is when the pollen goes from the anther of one flower to the stigma of another flower. And when pollination happens, then the flower itself can finish the job of fertilization, where the ovum and the pollen grain meet, and that they're able to either create seeds or fruit, things that we like. So very important for many flowers. That was just a quick review. If you go online and try to figure out, are bees vital, you'll quickly find this, which I just pulled right off the internet. And it says from Albert Einstein, if the bee disappeared off the face of the earth, man would have only 4 years left to live. So clearly bees are vital, but since this is from the internet, I'll just give you a little correction here. Albert Einstein did not say that. And as a matter of fact, it's not true. So bees are vital, but if they disappeared, we wouldn't die in 4 years, because I don't know about you, but I like corn. Corn's a staple, nothing to do with bees. Corn would get along fine. It's wind pollinated. Same with rice. Another staple, all the way down the line. So we have a lot of things that we would still have without bees or pollinators, but they'd kind of be the boring stuff and not the fruits and nuts and stuff. So just to prove to you that bees and pollinators are vital, the White House put out a fact sheet. Honeybees enable at least 90 commercially crops to be grown in North America. So some of those crops would almost have nothing to harvest. Some of them would just have reduced harvest. So bees make it completely possible for some fruits, but they also make it more, make the harvest bigger. Pollinators are vital to keep fruits, nuts, and vegetables in our diet, also according to that. So this is a cherry. I got it out of a bag at Giant. And it's, I don't know, you guys probably know this. This is something I learned. It's one druple. So that means there's a seed in the middle and there's flesh around it. But that came from one blossom, and that one blossom had to be pollinated so that the flower could fertilize itself and grow the fruit. So what happens if it didn't get pollinated, probably by a honeybee? Then you end up with that. So these flowers were right next to each other. And the one on the right was pollinated, the one on the left wasn't. Like I said, I got this out of a bag at Giant, but I took the picture and I sent it to the extension service in Michigan, because they have great cherry orchards there. And they confirmed that, yeah, that left one wasn't pollinated. And he said that happens a lot more than you might think, but we never see it in the store. I was lucky to grab this because they fall off before they get to the consumer. So raspberry has 75 to 85 drupelets. Each one of those little balls came from a tiny little blossom, and each one of those blossoms needed to be pollinated. So what happens if they're not? Not so great. And I took this in my garden, and the reason it wasn't pollinated is honeybees do this weird thing. They fly out, but they immediately go up high. And so these were close to my hive, and for whatever reasons, they seem to ignore that particular one anyway. Whole Foods did this really cool thing where they showed all the produce that is made possible with and without bees. So this is what their produce section would look like with bees, and then they took stuff out. So, like I said, a lot of things that we like to eat would disappear or become less. Something that's not vital, but I like it, is my honey that I get from bees. Honeybees are the only insects that produce this excess honey that we can harvest. We also harvest pollen from them. If you go to Whole Foods or another store, you'll see these bags of pollen, which are high in protein, and some people they have a kind of a nutty taste. We're from the DC area, so if you're like me, you see these trees and blossoms, then you immediately recognize them as cherry blossoms. They're not. This is in California, and they're almond trees. They have 1.34 million acres of almond trees, and each one of those blossoms needs to be pollinated by a honeybee. And they don't have, in all of California, enough honeybees to pollinate all those. So what is the answer? They truck in some honeybees. That's another beautiful thing about honeybees living in man-made hives that are modular, and you can pack them up and put them on a truck and take them places. In the case of the almonds, they move 2 million hives to California. So where do you even get 2 million hives, which contain 42 billion bees? Well, pretty much you got to pull them in from all over. It's actually one of the biggest insect migrations in the world that's completely man-made. So why honeybees? Why are they so irreplaceable? Why are they such great pollinators? they live in these huge colonies. So compared to bumblebees, for example, bumblebees might have tens of individuals living in a colony. Honeybees have tens of thousands of honeybees in each colony. So they're easy to move around in huge numbers. They also have this interesting characteristic called flower fidelity. So what is that? So if you have honeybees pollinating your crops, you need to have them take pollen from one plant to the next plant, but it needs to be the same plant. And for whatever reason, honeybees, each time they leave the hive and go out to collect nectar and pollen, on that particular trip, they only go to the same kind of flower. So strawberry, 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 spreading the strawberry pollen among it. A bumblebee or other bee or other pollinator might go strawberry and then something else, dandelion, apple, whatever, and moving that pollen to a different species is not pollination, doesn't help fertilization, and it's not useful to the plants. So the honeybee goes out about 12 different trips. And so on the first trip, it might go all strawberries. Second trip, it might go all peaches, whatever. But each individual trip, when it gets the pollen, it's going to the same plant. The other interesting thing and useful thing about why they're great pollinators is honeybees live through the winter. So bumblebee, they all die except for the queen, who hibernates. In the spring, the queen comes out, lays a couple eggs, has to go collect food, raise those few. Those few then, when they become adults, help raise more, but it's a very slow process. Honeybees start spring with tens of thousands of individuals. The queen just has to keep laying eggs, eggs, eggs. The other bees take care of the babies, and so they build their numbers up really fast in the spring. When they're out foraging for flowers, they go 3 miles. So honeybees have a huge area that one hive can go to. My hives, you might be within my 3 mile radius, and my bees might be in your yard. So thank you for the flowers. But a bumblebee, maybe a few hundred yards. So very close. The anatomy of honeybee is just made to handle pollen and move pollen around. They are covered with these special hairs. They're like little tiny feathers, and when the bee flies through the air, it collects this static electric charge. So when it lands in the flower, the pollen literally jumps up and is attracted to the bee, and then it gets stuck in all that branching hair. And so as the bee moves around, some of it falls into the next flower, pollinates it, and we get to have amazing fruit. But the one thing that I learned as a beekeeper is that pollination is completely accidental. So I knew bees were really important and they do the pollination, but they're just out there collecting the pollen for themselves. And when they go to the next flower, it just accidentally falls off. As I said, they just get covered in pollen, but their body with the Swiss Army knife is made to help move around that pollen. They have all these hairs, stiff hairs on their legs that are combs, and they brush through all those plumose hairs, the feathery hairs, and they move the pollen back to this pollen press. It's kind of like an elbow. And if you bend your elbow, it presses the pollen, it compacts it, and they move it into this pollen basket, which lets them carry millions of grains of pollen back to their colony. And this is the outside of my kitchen observation hive. This is where they come in and go out. And this is 1/8 speed of that bee bringing the pollen back to the basket. So bees do everything really fast. So by example, these bees are bringing back a lot of pollen. Why they're moving so fast, you can't even see their pollen baskets. When they get back to the hive, they put it in their honeycomb storage areas, and they pack it back. And if you did a cross section of that, you would see all these different layers. So why are they different colors? But remember, the honeybees went only to one type of flower, which had one color of pollen. So when they came back and put that pellet in there and pressed it back, it became a layer of a certain color. And then when they went out and got a different pollen from different source that made the next color, as you see there's oranges and purples and all different neat flavors, colors. But the different pollen has different protein content and different kinds of protein. So just like for humans, a variety of pollen is really important for the honeybees, which is another thing for you that you guys are so helpful with, because of the variety of plants that you help put out there. So you just saw how the pollen is stored in the hives, but when you go to the store, the pollen looks like this, different. So how do we get that? Well, beekeepers have this special little pollen trap, kind of mean. The bee on the left is coming back, and we put this just a couple days on the entrance of the hive, so that all of a sudden the bees have to go through those small holes, which are big enough for them, but not for the pollen pellet. So they have to take it off, and it drops down into that collecting container at the bottom. So that's why in the store, the pellets look like what the bees brought back and not how they store it in their hive. So bees are, another reason they're irreplaceable is they have language. They're the only creature besides man that has symbolic language. This bee right here is doing the waggle dance. You've probably heard of it. So encoded in that dance, the bee is telling the other bees the distance and direction to find a good source of food. So they can take a little sample from the bee, so they know what the bee's telling them, what the honey smells like, and the nectar smells like and tastes like. But they know exactly where to go. And this is a Nobel Prize winner. A scientist won a Nobel Prize for figuring this out, deciphering it. So if I look in my observation hive, or more likely if a scientist is looking in their observation hive, they know where that bee is telling the other bees to go. They can go in that direction for approximately the distance that the bee is communicating, and they'll find the other bees coming there to get the flowers. So why is that important? Besides just being brilliant and having language, think of the poor bumblebee. The bumblebee goes out, it doesn't know where it's going to go get its next meal, or collect pollen or nectar to bring back. So it wastes time. These bees know right where to go. Very efficient. This is the dance explained a little bit. The straight part there where it does the waggle is the one that encodes the distance. So the angle from straight up towards the direction tells the other bees the direction to go get the food based on where the sun is. They navigate by the sun. And the length of that little waggle is the distance encoded. So how do they make honey? it's a bunch of steps, it's quite labor intensive. So they go out to the flowers, and you know this part. They collect the nectar out of the flower, and there's not very much nectar in each one of those flowers, just barely a little moisture drop. But they go to enough that they have another Swiss Army knife device inside them, just like the pollen. They had a special basket outside to carry the pollen. Inside, they have a special little compartment before their stomach that called the crop that helps them collect a huge amount of liquid to carry home. On the way home, they're adding enzymes to it. And once they're in their hive, they spread it out. They don't just put it in one place, they spread it out, and they take it back out and they blow bubbles with it. The whole reason to do this is nectar is 80% water. Honey is 18% water. So they have to dehydrate it, and they actively dehydrate it by blowing bubbles and moving it around. They also passively control it by controlling the humidity inside the hive. If they keep the humidity low by blowing out the excess moisture, then the nectar can dehydrate faster. But the trick is they have to do this over and over again, because they go back, the load that they bring back each time gets dehydrated down from 80% water to 18% water. So they lose all that volume. But once they finally do get that water out, then they cap it. If you look at the bottom of the screen, you can see that the cells have a wax capping over it. That's to keep the moisture out and keep it clean and ready. Why do bees go to all this work? Because remember, they live through the winter when no flowers are available. So they're just storing food, the pollen, as well as the honey, so they can eat it through the times of dearth when there's nothing out there. It's also very efficient, right? So if they just stored the nectar, first of all, it might ferment, but second of all, it's not very spacious efficient, right? So they've condensed it down. So how do we steal their honey? First thing we have to do is remove the cap. So I just have this as an example. This is one way to do it. There are faster ways to do it. You could see the honey underneath. Honey is very viscous. We have to put it into an extractor. You can't just turn it upside down and knock it out. You have to spin it really fast. And so this extractor, the honey comes out of the cells, sloshes on the sides, and then goes down, and we strain out the wax cappings. So I want everyone to be able to go home with just a few facts that you can memorize and astound your friends and all the other master gardeners that aren't on this call. So here's the first thing. It's my favorite. You'll love it. The trivia question is, how much honey does one honeybee make in her lifetime? So I really regret that we're on Zoom, because I love to have people call out their answers. And I want each of you to think in your own mind what that would be. So I'll call out ones that they often heard. Some people say one bee in its whole lifetime makes a gallon of honey. Some people have said a cup of honey. Some people say a teaspoon of honey. The answer is 1/12 of 1 teaspoon. One bee in her whole lifetime makes only 1/12 of 1 teaspoon of honey. How can that possibly be? How can that be possible? You go to the grocery store and it's stacked. Well, it's all in those numbers. So tens of thousands of bees in each hive all do their own little tiny contribution. So hopefully, knowing how hard that bee works, you guys will take good care of your honey, keep it in an airtight container so that humidity doesn't get in. They went to all that work to make the honey concentrated. So if you do let too much water get into the honey, then it might ferment. But if you keep it dry, honey's amazing. It has antibacterial, antifungal properties when it's concentrated. You probably don't want to put it in your refrigerator because refrigeration makes the honey crystallize faster. It's just the right temperature for it to crystallize. Crystallization is not bad, but all honey crystallizes. And sometimes the crystals will sink to the bottom and look like that, but it's still great honey. There's nothing wrong with it. Don't throw it out. It's very easy to restore it back to liquid. Just put it in a little warm water. Don't boil it. That would hurt the flavor. Don't put it in the microwave. It gets too hot. And if you put it in the microwave in one of those little squeeze bears, then you'll probably end up with a huge pool of honey at the bottom amongst melted plastic. But anyway, if you have a sous vide, that's actually how I do it. But leave the cap on. I got this picture off the internet. It's not good. Some people like their honey crystallized. Some people pay more. This is called whipped honey, or sometimes creamed honey, even though it is pure honey. There's no dairy in it, but it just sometimes people like it. It's easier to handle, to spread on bread. Doesn't drip. You've probably heard of honey varietals: orange blossom honey, buckwheat honey, lavender honey. Each one of those tastes very different from the other ones. But what does that mean exactly? Well, if it's orange honey, then it was from hives that only really had access to an orange grove. If it's buckwheat honey, same thing. It was where there's buckwheat fields and not much else for quite a while, for quite a ways. Lavender honey, it was near lavender fields, but when I look at this, I want to go there. I can't imagine what that must smell like walking down those rows. But there's more than these three varietals. There's an entire list, and people have tried to figure out what those honeys and other honeys taste like. My honey from one hive to the next hive tastes different. Those bees had different preferences of which flowers they went to and the way they did it. But a university made up this flavor wheel. It's kind of like you might have for wine. So some of my honeys might taste like this, fruity, tropical fruit, and then some of the specifics are more apple, peach. It's not that they are from those particular plants. This is not talking about the varietals that I just mentioned. This is just a taste test. So my honey might come from this side of this wheel. My honey never tastes like anything on this side of the wheel. I want to continue with some amazing body parts. This is partly how I fell down that rabbit hole of honeybees, because that Swiss Army knife. So how many eyes does a honeybee have? This is another trivia question that you can take home to your friends. I wish you could shout it out. Most people yell out 2. Some people yell out 1,500, but they're talking about the facets on each eye. So honeybees have these 2 big eyes in front, but they also have other eyes on the top of their head. They have 3 more up there called ocelli, and those help them see where the light's coming from. So it helps them see the light intensity. That helps them fly. Up is usually brighter than down below. That's actually why bees have trouble flying over water because of the reflection. And in the winter, they have to come out. They make little cleansing flights, it's called. They don't defecate inside the hive. They have to wait till it gets above 45 degrees. They hold it all that time for 1 month, 3 months, whatever. Then they come out, make a quick flight. But if there's snow on the ground, sometimes it's brighter than the sky and they get confused. They fly upside down. I find them in front of the hive upside down and frozen to death. So kind of sad. But these big eyes are called compound eyes, and they have the same kind of range as humans, but their vision is pushed down the spectrum some. So they can't see red, but they can see ultraviolet, which is really cool. Maybe you guys, if you guys could see your flowers in ultraviolet, you'd see that they look different. In normal light, this dandelion looks all yellow, but the bees see it with a target painted on it of where they need to go to get the good stuff. And so the plants are helping them out and guiding them straight to the important part, which if there's a whole bunch of yellow, that could be really helpful. Another part of the bee that I find really fascinating is their antenna. You've all seen different insects flailing their antenna around, but they have an incredible amount of sensors on there to figure out the world. They have the sense of smell on those antennae, taste, humidity, temperature, touch, gravity, important for when they're inside the hive and they're communicating with that waggle dance to know which way's up and which way's down, because that helps them know the direction that the waggle dance is conveying to them, helps them with this flight speed and sound waves. I just want to point one thing out that's really cool, and I'm a little bit envious of, back up at taste. So how cool would it be, like, if you get in your refrigerator and you see something a little bit old, instead of like putting it in your mouth and having to spit it out, just touch it with your antenna and, oh yeah, okay, that's still good. So that would be a cool thing of being able to taste without putting something in your mouth. But the flip side of that is honeybees also can taste with their feet, which is a little weird and something I would not want to have when I'm walking the dog in the dog park. So I guess there's trade-offs. I love micrographs. This is their antenna, all the different sensors sticking out there. And here's an even closer view of these tiny hairs and pits that help them sense their world. But back when we were talking about pollen, remember, they get covered in pollen, which is going to interfere with how they're able to sense all the world. But the Swiss Army knife to the rescue, they have in their front leg this special device called an antenna cleaner, and they can just put it around their antenna and run their arm down, and it cleans off all that pollen. So honeybees are also very unique in that they act as a single organism, a superorganism. So one colony is very comparative to just a body, one animal, and the cells in that body are made up of all the different bees, and bees do different functions. One of the interesting things is inside that hive, remember that each of the individual bees is breathing in and breathing out, just like us. So breathe in oxygen, breathe out carbon dioxide, but it's an enclosed space. So if the carbon dioxide level is going to get too high, just like our lungs are an enclosed space, and carbon dioxide gets too high there. So what happens is certain bees start fanning their wings in special direction, and they control the flow. And as a whole, they breathe out the carbon dioxide, and then other bees pull it in. And if you puff smoke in front, you can actually see some of the smoke goes in and some of the smoke gets pushed further out. So They're like a superorganism. They act together and they breathe. They control the humidity in there. I mentioned that helps with the honey. They also control the temperature. So this is another mind-blowing thing for me. And another thing, another trivia you can say. So honeybees, like all insects, are cold-blooded. They don't regulate their own body temperature, but as a whole, they do regulate the temperature of where they're raising babies. So they keep their babies inside at 94 degrees. Sounds similar to our temperature. And even in the middle of winter, when it's 20 degrees outside, if they're raising babies inside the hive where they are raising their babies, they keep it 94 degrees by using that feathery, their feathery hairs and clustering together, but also in the middle of that cluster where the brood is, there are certain bees that are called heater bees, and they shiver their flight muscles and they send their own body temperature up to 104, and that helps radiate heat and keeps the other bees warm. So pretty weird. They also have meta reproduction. So inside the hive, yeah, the queen's laying an egg and that grows into adult and they're making more babies and more adults. So that's reproduction. But at the end of the day or end of the season or the next year, that's still only one colony of bees. So that's not meta production. So in order to get really more bees, they swarm. On the right is a picture of a swarm. Some of you might have had them in your house every spring. If people go onto our website, they can report a swarm, and it comes to me, and I'll send a beekeeper out to collect the swarm. But what's happening is the colony has split in half. So just like an amoeba reproduces by splitting in half, where you had one, then you have two, the honeybee colony also splits in half. So the queen and half of the worker bees fly off and start a new colony somewhere else. They rest for a minute as they get everything together. That's what that swarm bivouac is there, cluster of bees. And so you have the colony that was left behind, half of the bees, they raise a new queen. And then where there was one colony, now you've got two. One stayed there and one moved on. The division of labor is the other thing that makes it a super organism. So they have cast members. The queen is has certain roles, and I'll get to it. The male has certain roles, and the worker has certain roles, and they can't do each other's roles at all. So a honeybee by itself can't survive. If you put a male and a female together, nothing's going to happen. It can't survive. 1,000 bees together can't even survive. It takes thousands of bees all working together to survive, and each of their different assignments, it's called cast members. It's my joke. You add an E at the end of cast, and that means that different bees have different functions in the hive. This is a little video of the queen. She's about to lay an egg. She's the only individual in the whole colony that can lay a fertilized egg. She's gonna first feel the size of the cell, then stick her head down, feel with her antenna. Then she's curling her abdomen back and laying an egg in the back. Now, as she did that, after she felt the size of that cell, because it was a normal size cell, as she laid the egg, she fertilized it with sperm that is stored in her body from when she made it. If she felt with her front legs and the cell was a little bigger, she would realize that the workers had made that so that she would put a male bee in there. if she doesn't fertilize the egg, which she's going to put in the bigger cell, it becomes a male. If she does fertilize an egg, which she would only put in the normal size cell, it becomes a female. So that's another mind-blowing thing for me. If I have a chicken egg and it's not fertilized, there's no way it's going to grow into a chicken. But if you have a bee egg that's not fertilized, it grows into a male. That's the only way to make a male. So the queen has glued that egg to the very back of the cell, and she can lay 1,500 eggs a day when she's going strong. That's her only job. She doesn't take care of the babies in any way. She doesn't get her own food. She's completely taken care of. So what's the drone's role? Well, it's not to protect or gather food or raise young or help the colony in any way. He helps his own colony in no way at all, because he doesn't mate with any virgin queen in his own colony. He flies away and mates with another colony's virgin queen. So that's good to stop inbreeding. So his only job is to mate, and he can live a couple months or until he hooks up. Because now some of you may need to turn off your screen, because we're getting to Sex Lives of Beasts, which is definitely R-rated. It's going to have sexual content, bee nudity, and stinging language, because here is an actual mating flight. Bees, unlike a lot of other insects, only mate in the air. On the right is the queen. She's flown a couple miles from her own colony. The males have flown not as far, but they're all congregated. Some weird thing. Nobody knows how this happens or why. Well, we know why. No one knows how it happens. The males congregate in the air in certain areas. So male bees from different colonies around all coalesce in the air, waiting for a virgin queen to fly above them, because she flies higher than they're flying. The males have bigger eyes and longer antennas, so they can see and smell the queen better, and they rush up to her and mate with her. So the males in the back watch his wings, because the second the mating happens, boom, his wings stop moving, because he just died. And now he's going to fall over backwards and fall to the ground, and his life is complete. A queen will mate with 15 to 50 bees, male bees, and then she will store that sperm from all those different drones in her body in a special Swiss Army knife, again, contraption called a spermatheca, which is like a sphere inside her body that stores all this sperm for years. Queens can live for years, and inside that spermatheca, they give the sperm food and oxygen and keep it healthy, so that it can last as long as the queen does. The workers do everything else besides laying the eggs and mating, which is just crazy. They feed the babies. They bring all the food in. They do that work of converting to nectar, and they control the temperature. But they also have another Swiss Army knife specialty on their lower abdomen. This is where the wax comes from. They have special glands that create the wax, and then other bees, or they use their legs, pull it out, use their mouth to kind of chew it up, add a little honey, and form it into all those hexagonal wax honeycomb cells. So we said the males have kind of a tough life, because their whole mission is to mate, and then as soon as they complete their mission, they die. But the females don't have it that easy either. This is a quick video. This female just got knocked off, falls down, hard knocks life. She tries to get up, boom, she just got knocked down again. I'm only playing this because I find it funny. Here's a slow motion of her, another bee coming in. Too sad. So what's killing the bees, and how can you guys help? There's 4 things. They call them the 4 Ps. And at the bottom of the list is poor nutrition. So that's really loss of habitat. If bees don't have the variety of foods and enough foods, then they can't survive. So at this point, I want to stop for 1 second and say that Washington Post and some other newspapers have had articles about areas that want to reduce the number of beekeepers. So the reasoning is they say that they're out competing the native bees. But and their answer is fewer honeybees. But I want to show you something. Which of these houses is more helpful to honeybees and native bees? Again, if we were in person, I'd make you guys shout it out. And what happens is people see the flowers hanging on the left house, and they say, of course, it's the house on the left that has flowers hanging for the bees, so it's better for bees. But the house on the right is amazing. They've replaced their lawn, which is almost worthless to bees and native bees, honeybees and native bees, with all these amazing flowers. And this is, if you guys could get a lot of lawns converted to this would be really helpful, which is to my point. It's not, if there's not enough food to go around, which in our area there is, it's only very specific areas in the country where it's even an issue of outcompeting native bees. But the answer is not fewer beekeepers who are attuned to nature and try to help with nature and convince other people to act wisely for nature. The answer is to have more food produced, so have more flowers. The third most important P is pesticides. So I think of pesticides as being on the farm, right? Because you always see the tractors out there spraying, but they did a whole bunch of testing. So where do bees encounter more pesticides? Out in agriculture with all those chemicals, or in an urban area where people live? And again, everyone shouts out, of course, it's the farm, but that's not right. It turns out that in urban and city areas have much more pesticides in the environment than on the farm. And it kind of makes sense because the farmer has a huge area, they're in business, they're not going to put on expensive chemicals except when they need it. So they use tiny amounts. But we just go to the store, grab something, we see an ant, we spray. We don't know how much we're spraying. We don't know much about it. We just saw that it said kills ants, whatever. We bring it home. So a lot of lawns and ornamental plants get a lot of pesticides put on them. Some of them come with neonicotinoids built in. They've been grown with this, and it's actually in their system. And the neonicotinoids, even though you didn't know you were buying it from the garden store, has this pesticide in it and exudes in the nectar, and get our bees get into it that way. The second most important thing that's killing bees, you can't help with. It's pathogens. Bees have lots of viruses and bacteria that affect them. And as beekeepers, we have certain ways that we can help them, but it interacts with the number one problem for honeybees is this mite. It's called the Varroa destructor mite. It only came to the United States in the mid 80s. It's not like our bees have had any chance to evolve with them. The Varroa mite eats. It gets into the larva when it's under the cap, and it eats a very important organ of that developing bee called the fat body. And the fat body helps the adult bee, which the bee can survive from being eaten on when it's a larva, but it has less of this fat body, and the fat body is kind of like our liver. It helps them filter out impurities like pesticides, and it helps them fight invaders like viruses and bacteria. So it's just this huge double whammy. The mite weakens the bee, and then it's more susceptible to these other things that they've been living with for a while. And the mite also is a vector for some of those diseases, which is really it's our biggest problem right now. There's no easy way. Every hive in the US has mites, and all the best the beekeepers can do is control the level of mites. So we treat them and reduce the amount. As I mentioned at the beginning, I wanted to send you guys home with some fun facts to impress your friends. One bee makes 1/12 of a teaspoon of honey in its whole life. Bees keep their nest at 94 degrees, even in the winter. And here's kind of like a riddle. The queen bee decides each time whether to fertilize an egg when she lays it, and the unfertilized eggs become a male. But here's the kind of crazy part: male bees have no fathers, but they do have grandfathers because the queen had a father. So I don't know, it's crazy. And when you're in your garden, you are going to be able to impress everyone there, because if you see a honeybee come there, land on one of your flowers, you can say, I know the sex of that bee. With 100% certainty, you can say that's a female, because the males don't go out to the flowers. They don't do any collecting of any food. So you're absolutely, and the queen doesn't go out either. So you know you've got a worker bee. Only bees you are going to see are going to be female bees. You've never seen a male bee unless you've been with a beekeeper. I wanted to leave you with a final little fact. This is a cartoon. We see it all the time. It implies that it's a honeybee hive. Honeybees do not make the exterior part of a hive. They only make the wax, which they create their nest inside a hollow place, like a hollow tree, or sometimes in a wall, or inside a little cave, whatever. But they never create this big ball. That's wasps. And I get so many calls. Oh, I've got honeybees. I know they're honeybees. And that's wasps. That's the end. I wanted to just thank you. Hopefully there will be a lot of questions, but I appreciate the opportunity to talk about bees.
Oh, thank you, Philip. I know it's about 11:30, and I see there's a lot of questions, but I think we agreed to answer all your questions, Bill. But I know your time is important, so I'm going to kind of do a quick little wrap up here. But also, we're going to stick around and try to answer all your questions, because I know people sometimes have other things on their agenda. So real quickly on my end, of course, I thank our speaker here today, Bill, and I appreciate all his time and sharing his expertise with us. Also want to thank real quickly our tech team here today for all their help. And I forgot to thank our nominating committee, Linda Barrett, Ann Hilliard, and Carol Kosery. One of the big things I want to remind everyone is to make sure that they enter your volunteer hours. And please, 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 please do that. So I encourage you to enter that. If you have issues, you can reach out to me or Renew or Katie, and we'll try to make sure you get it. So that's your service hours and your continuing ed hours. To get those in, enter before the end of the year. It's not that far away. And there's not that many more opportunities to volunteer. I mean, there are a few, but it's really winding down. So if you need to, don't wait till the last minute sometime in December. There's not a lot to do. And C was just about done. Hope to see you guys at our holiday party on December 7th. And I just want to give a little shout out from Montgomery College. Stanton Gill will be teaching his fruit production class again this winter. It was very, very popular. Stanton, most of you know Stanton. He's going to have it's be a hybrid class online, but also I'm sure you can go out to his orchard as well. And sort of as a follow-on to what Phil was talking about today, we are still let's try to plan to add on a course, a beekeeping course, this coming spring semester up at Montgomery College, and it'll be taught by Greg Gocknauer, who's our local bee inspector from the Maryland Department of Agriculture. He's been doing it for like 25 years. He's a retired school teacher from Rockville High School, science teacher. So at this point, I think I'm going to hand it over to Chuck and the rest of the tech team to answer your questions. But I know if some of you have to go, that's great. But we got a lot of questions here. I'm going to let Sue and Chuck take it over from here. But thank you, everyone. If you got to go, I understand. But hopefully you'll stick around and hear some of these questions answered by Phil. Thank you.
Thank you, Steve. And thank you, Phil, for an amazing presentation. The first question that came up was actually one I had as well, which is, how possible is it to have a deck-based apiary? Can an amateur do it? How do you start? Is there a minimum number of hives?
Okay, those are all great questions. So it's the honeybees are not aggressive, so it's very easy to have them on your hive. As far as starting, you definitely, Steve just mentioned the beginning beekeeper course. There's a lot to learn. The learning curve is huge as far as just getting in. You mentioned at the beginning that I had a years-long program and became a master beekeeper. You can't even get into that program till you've been a beekeeper for 5 years. And the way I consider it is, now that I have my master beekeeping certificate, I'm ready to start learning about bees. It keeps going, but don't let that stop you. It's a fascinating hobby, and you learn so much more when you have your own bees. Just take your course, and it'll be a lot of fun.
Thank you. Are copies of your book available?
Yes. It's sold on Amazon. It's $25 on Amazon. If you live in the Bethesda area and you want to pick one up from me, I give a 20% in-person discount. And depending on my time, I might show you my observation hive too. So just contact me. So 20% off of 25 is $20 a book. I'd really like to sell a couple, so that'd be great.
Cool. Flower Fidelity, you said they go out and only visit one. Do they make 12 trips each day? Does each bee go like 3 miles, or some are long haul bees and some are short haul?
Great question. So bees actually do have personalities. They tend to do things differently than others. Some of them like to go out and gather mostly pollen. Some of them like to go out, gather just the nectar. Some of them, other things that are needed in the hive is water, which helps them thermoregulate. So in the summer, they bring water in and they put little drips around, and that evaporates for evaporative cooling. So if it's too hot outside, they still have to keep the brood nest at 94. So bees are also, remember, so intelligent. So they have a cost basis of which flowers they're going to go to. So different flowers don't make equal nectar. So for example, the tulip poplar tree has lots and lots of nectar that it produces, but the sugar level is low. Other flowers have high amounts of sugar in their nectar. So they actually figure out, okay, is it better to fly 1 mile and get this low sugar, or fly 2 miles and get this high sugar? And they figure all that out and go to the best place and bring it back. And yes, they make about 12 trips a time. Each trip they visit hundreds of flowers.
Cool. Well, and are there shade plants that are good for honeybees? And also the question was about single level petals versus multiple level petals. Are there certain kinds of flowers that are easier for bees, or?
Yeah, great question. I can refer you to the website that I mentioned that has a whole list. There are fewer flowers that in the shade, but there are flowers that are good for bees that can tolerate shade. And the multi petal, it's a flower by flower specific answer, but yes, some flowers are harder for bees to get into. And also the length of an insect's tongue determines which flowers are accessible to it. So some other species of bees have longer tongues and are able to get into deeper flowers that a honeybee can't get into. So that flower wouldn't be useful to the honeybee. And there's also, like, for example, tomatoes. Tomatoes, the pollen on a tomato is very held on very strongly. And so it's not very easy for a honeybee to get that pollen, but that's why bumblebees are really important. They do this thing called buzz pollination, where they actually grab the flower and they shake really hard, and that's how they get the pollen out. And then that's why they're more useful for tomatoes.
And just to remind anybody who came in later, that website was montgomerycountybeekeepers.com that you put at the beginning. If
Right.
you could put into the chat how to contact you to buy your book, people have been asking. Do the bees make the wax, all the perfect little compartments? Do the bees actually make those?
Yes, it's really fascinating, and you can see it in my book. They have the glands. The workers have glands on the bottom of their abdomen, and at a certain age, they put out the wax, which they chew up, add a little honey, and they use their mouth parts to pat it into hexagons. And hexagon is the most efficient way because it shares walls on each side. So you get the most storage for the least amount of construction material. Wax is really expensive for honeybees. And what do I mean? They have to consume 9 pounds of honey to make 1 pound of wax. So it's not something they want to do when they don't need to.
Do you leave some honey before the winter for the bees to use over the winter?
Absolutely. That's part of being a good beekeeper, is knowing how much of the honey you can steal and how much you need to leave with them. And the general rule in this area is you need to leave about 60 pounds of honey on the hive so that they can last through the winter until the spring flowers start coming out.
Can humans eat the wax on those hive panels that you showed skimming it off?
Yeah, I actually, when I'm working harvesting, I chew on those wax cappings because they're sweet, but I don't swallow the wax. I just do it like gum and then spit it out. But yeah, wax is edible if you want it.
If the pollen is so important to the bee, why would people harvest it from them? And you said for a few days?
Yes, that's a really great point. And so also like the honey, you can't take too much pollen from them. So you just put it on for a few days. In our area, bees actually collect too much pollen. So the frames get what we call pollen bound. The entire frame is filled with pollen, and they do this really cool thing. They add things to that pollen and that help it ferment, and it actually increases the nutritional value of the pollen. And they also put a tiny little bit of honey on top to help preserve it so it lasts through the winter. But yeah, you just put those on for a couple days, and you monitor how much food they have, both pollen and honey.
Do bees have natural enemies? Somebody mentioned a bear pulling their hives apart.
Yes. Yeah, there's a whole bunch of predators. And again, it's the beekeeper. If you've got bears in your area, you have to have an electric fence. And sometimes that's not even enough. Bears really, they destroy the whole thing. But raccoons come in and also do it. Another very common pest are mice and shrews. So in the winter, the mouse is looking for a nice warm place to go with plenty of food. And what better place than a protected beehive that's kept warm by the bees and has all those food stores. So one way we keep it out is we shrink the entrance to make it big enough for a bee to come and go, but the shrew and the mice not. I never even heard of a shrew until 2 years ago. I didn't think I heard of them, but I didn't think we had them here. But one of them killed one of my hives over the winter, and it was really sad. How do I know it was a shrew? Because they don't stay in there. But there was a pile of dead bees at the bottom, and all of them had their heads bitten off and their insides eaten out. So that's a typical sign of a shrew coming in. And so I had to make my entrance even a little smaller. I'm just typing my email in the chat.
Perfect. That's what I was going to ask you to do that. And then I've got like 2 questions left. And thank you so much for your generosity and your time.
I love
This
it.
has been fascinating and entertaining. So one question was, I'm confused about the issue of language. Don't many other species communicate within their communities?
Yes. So the difference is I can communicate to you by saying, if I'm in the room with you, say, go get that glass on the table. I've communicated to you, but that's not symbolic language. And what I said was that bees have symbolic language, which would be us being in a different room and me explaining to you which item I want you to go get. And that's what they do. So they don't, when they do their dance and they do a certain angle, that angle, the wax comb is vertical like this. So when they point, it's never going to be east or west. It's going to be up or an angle from up. So and the distance is how much how long they do their waggle in the straight part of doing the figure 8 dance. So they're the only other animal that can use that symbolic language.
Cool. And the last question was, we've all heard about unethical production methods for meat. Are there unethical production methods for honey that we should avoid as consumers?
Oh, that's interesting. I've never had that question before. I don't know the answer. I can't think of something that someone would do. So I'll give you an example, an older example. So pre 18 late 1800s, people kept bees in skeps, and a skep is kind of like a woven half of a basket. You would recognize it instantly because it's used everywhere as a symbol of honeybees. The way to get honey out of there is to kill all the bees. You just, at the end of the season, you open it up and you smash all the comb and strain out the honey, because you can't leave it intact because it's all attached to the inside of the basket. And the ancient Egyptians used to do a similar thing, except instead of a woven basket, they had like ceramic tubes that they kept the bees in. And each time they harvested, they basically killed the colony. That's illegal now. So it hasn't been done for a long time because Lorenzo Langstroth in the mid 1800s invented movable frames. If you were in the beginning of the talk, you saw me pull this frame out of the hive box. So I can take out the honey, and I can take out the frame and brush off the bees and have just the comb, and I can take the caps off and take the honey out, and then I can give them that sheet of wax comb back, which saves them a lot of work and saves honey. And so I think we are in the more ethical area. I don't know anyone that would do it differently.
And I can imagine ancient Egyptians, there was a lot more habitat for the bees than there is today. So it seems like a wonderful partnership. This has been wonderful. I can't thank you enough. I think everybody out there, if you read the chat, we've just enjoyed it so much. I'll tell you that we've kept a lot of people to hear all these questions. So thank you, thank you, thank you. You put your email in so that we can get in touch to come get your book. And if we're really lucky, see your hive.
Yes. Wonderful. All right. You can also reach me through either of those websites, Montgomery County Beekeepers.com or mdbeekeepers.org.
All right. Well,
thank you so much. I really appreciate being able to talk to you guys, especially you guys, Master Gardeners.
Well, we are very grateful to you. So, and on behalf of Steve, if you ever want to come back, I can't imagine why we wouldn't want to do this every couple of years.
I'm ready.
Wonderful. Thank you. And
Thanks
thank you to all the Master Gardeners out there. Renew, did you want to add anything? I caught her off guard.
So thanks, Phil. Yeah, thanks, Phil. I'll wind it up here, guys, and hope you have get some time to enjoy. It looks like nice weather outside. Might be cool, but yeah, get outside, do some gardening this weekend. All right, I'll hope to see some of you guys soon. I'll wrap things up here, probably shut things down. Again, thanks, Phil. We'll be in touch. Thank you very much.
Thank you.
Thank you for making it.